Okay friends, see, as you know, we are commencing a new chapter in your 10th standard electricity. Okay, right. Now this chapter in your textbook is with the way it is written, it means that you should have some background of what is charge, what is, where does it come from, okay, etc., some things like that. Okay, so with that in mind, this chapter has been written. All right, but I am sure that most of you are not connecting things like that. Okay, so let me take you. Let us start the journey from that is atom. All of you know something about atom. We have already learned quite a bit of atom in your chemistry. Plus, you have also learned about valency, some reactions, etc. All those things. All right. So here we go. It is a well-established theory. Matter has atoms, of course, because see, electricity is all about the charges and flow of charges, right? So you must have a firm background, the fundamentals about these charges, electric field, potential, etc. All that you will get to know one by one. So a well-established theory that matter has atoms, and all atoms have protons and electrons. They coexist within atom, but separated by significant distance compared to the size of atom. Okay. Now, if you look at these constituents, what are the constituents here? You have got protons and neutrons here, and electrons are revolving around it. Now, protons, neutrons, electrons, all of them have got charge and mass. Charge and mass. Okay. Now, I would like you to understand that there is one force in the nature. Okay. See, in your 7th standard, 8th standard, you have studied different types of forces. Some forces you are introduced to, like gravitational force, frictional force. Now, you will get introduced to another type of force called Coulombic forces. Okay. Now, I think in the Dalton theory, you have learned, how the atomic structure is there. Right. So here I am just focusing on the electrical aspects of atom, mainly the electrical aspects. So protons are found to be heavy compared to electron, just like Earth and small object. Okay. Earth and Moon coexist with sufficient distance between them in spite of strong attraction due to gravity. So there is gravitational force between Earth and Moon. But Moon is revolving around Earth. Earth is you can say it is, with respect to Moon, it is at rest. Okay. However, Earth is revolving around Sun. That is different aspect. Now, what I would like to point out here is that there is a force between the electron and the proton. So, and the force vectors are same on both. So, the proton should move towards electron should move towards proton. Correct? But that is not happening. Just like how you take a ping pong ball and you throw it up. The ping pong ball moves towards Earth. Earth will not move towards ping pong ball, even though the forces are same on both of them. Okay, so I would like you to appreciate that. And therefore, I have given you the statistics. You can see the mass of the electron is 9.1 into 10 to the power of minus 31 kilograms. Mass of the proton is 1.6 into 10 to the power of minus 27. That means the mass of electron is how much? 10,000 times, approximately 10,000 times less than the mass of the proton. So it is very, very small mass. Okay. So even though there is force between the electron and the proton, okay, the proton will not move towards electron. Okay. Then this is because, okay, now since I told electron and proton have got masses, just like how Earth and Moon. So Moon is revolving around Earth. Why Moon is revolving around Earth? Because of gravitational force, right? And now understand that the gravitational force is attracting the Moon, but Moon is not falling into Earth. Why? Because Moon is revolving around Earth, and for any body to revolve, it needs centripetal force, and that centripetal force is given by the gravitational force. Now, how much centripetal force the Moon needs? mv square by r. That much only is provided by gravity. Nothing extra, nothing less. If the gravitational force was slightly more than mv square upon r for moon, then moon would have fallen to earth. Or if the gravitational force is slightly lesser than mv square upon r, then the moon would have told tata bye bye and it would have gone away from earth. Okay, so both is not happening. So the centripetal force, the entire centripetal requirement of the entire centripetal force is given by the gravitational force. Now, in a similar way, I am not telling you same way, in a similar way it is happening in the atom. So the Coulombic force, the force between the electron and the proton. Okay, so it is exactly similar to the attraction of moon and earth. Okay, so and protons are positively charged, electrons are negatively charged. So therefore there is this force, and this force is exactly equal to the required centripetal force. Okay, and therefore electrons are able to revolve. So what I am trying to point out here is that, proton has mass, electron has mass, then just like earth and moon, electron would have existed. But looking at the masses, okay, it is very clear that electrons need more force than the gravitational force between proton and electron. So there has to be one extra force, some different force, and that force is the Coulombic forces or electrostatic forces of attraction. Yes, please.
Last part what you told I didn't understand.
Pardon?
Last part what you told I didn't understand.
There is Coulombic force between the electron and the proton.
So like, because the electron has very less mass, so it has to get.
Yes, electron has very less mass. So if see mass is there, so there should have been gravitational force between the two. So scientists calculated the gravitational force between proton and the electron. They found it was very less, and because the electron has to revolve around the nucleus, so there must be some other force which is ensuring that the electron is revolving. So that thought gave rise to the idea that yes, there is some force called Coulombic forces. So like that, scientists should see, they should get a feel of it. Oh, this is not there, there should be some other force. Okay, so that is how the origin started. Okay, of course other Dalton experiments itself proved that, okay, and many experiments in chemistry, it is proved that that atom is not there is a lot of hollow space in the atom. That means electron and proton are not joined together, they are separated. Okay, and further experiments conducted at Rutherford and all have proved beyond doubt that electron is not not attached to proton, but it is revolving. Okay, and therefore the Coulombic forces has to be there. Got it? Studies and experiments have established that proton has positive charge and electron has got negative charge. Electrons are revolving around bunch of protons and electrons. So protons and neutrons. So neutrons is another subatomic particle, but it has no charge, it has got only mass. Okay. At the center of atom, a region where protons and neutrons are held together is called nucleus. And here you see, question is, protons are positively charged. So positively charged element quantities, they will repel. Only oppositely charged particles will attract. So in the nucleus, the protons are existing with the protons. Okay, they are not repelling. Yes, even though there is a repelling force, Coulombic forces are repelling the protons within the nucleus. There is another force called nuclear force, which is binding the protons. Did you understand? See, what I am trying to...
Nuclear force only bind the protons.
Protons and neutrons. Nuclear forces bind the protons and neutrons. So this is how you see scientists get an idea that, oh, there must be a force, because protons and protons, how can they coexist? They should repel according to the classical theory. But, well, they are not repelling. Okay, even though they are repelling, there must be some other force which is strongly binding it. Okay, so therefore they said, well, there is some other force called nuclear force. So there is a chapter on nuclear physics, there you will understand more about that. But right now get introduced to the fact that there are charged particles, protons and electrons, and there are forces, Coulombic forces, gravitational force and nuclear force. Yes, Sneha?
Sir, protons will repel, or protons and neutrons will repel?
See, neutron is neutrally charged, neutral, Okay, it is not going to be attracted or repelled by proton. Okay, and a neutron with another neutron will be attracted by gravitational force, and neutron with proton will also be attracted by gravitational force, and proton with proton will also be attracted by gravitational force. Did you get it? So there is this type of forces, and proton has to repel. But there is another force which is binding all these components in the nucleus and keeping them tight. That is called nuclear force. Now understand this very carefully. This nuclear force is only present in the nucleus. Okay? It has got its own characteristics, which you will understand in the future classes. But right now it is important for you to appreciate that there exists a force which binds the nucleons. Nucleons means protons and neutrons inside the nucleus. Okay? Now if you take any two particles and bring them, say, supposing it is not possible, hypothetically if you take two protons and bring it here, they will repel. Understand? But in nucleus, it doesn't happen. There are reasons for that. There is some more theory for that. You will learn in your higher classes. Okay? Now you should appreciate every aspect of science very, very carefully. Because every force that is going to be introduced will have its own characteristics. They behave like this under so and so circumstance. And that is all that you have to have the clarity. Alright. So I give you the statistics here, how the atom is, okay, and it's important for you to appreciate that Coulombic forces, nuclear forces, all these forces do coexist. Okay, fine. You have any question? You have some question?
Sir, that
Please.
interest in something.
Where is it?
The third both lines.
They are found to possess two important intrinsic properties. Good. Intrinsic means huttu guna. See, my nose was there when I was born. It is not that my mother went to market and placed it. So it's an intrinsic property of it. So what it means is, the moment the electron and proton are born, I should not use the word born, they are all, the moment it was created, or no, who created and all, now let's not get into the debate. The mass and the charge was inherent in that. Okay, now that also means like this, you cannot remove the charge from the electron, or you can put a charge to the electron. Understood? That is the intrinsic property. That is what I said. Okay. Good question. Okay, any other questions, students? Right. So I'll go on. Yes, please.
Sir, is centripetal force less than the Coulombic force, because of which Coulombic force it overacts upon centripetal force and
you got it wrong. You completely got it wrong. Okay, I'll explain. I'll explain this.
Please.
See, now, see, what is centripetal force? See, now here you have a circle. So in the circle here, okay. So in the circle here, you have got a body, right? And this has got mass m, and it is moving with speed v. Assume that it is performing uniform circular motion in this circle of radius r. ठीक है? Sanidhi, I am asking you, ठीक है?
Yes, sir.
You should keep telling her because I want to make sure it is right. So there is mass m and it is moving with velocity, with speed v. Okay, in circular path. Now
Yes.
this quantity, if it has to move in circular path, now the basic mechanics, if you see, right? So here you see there is velocity vector v1 bar, and when the particle is here, the velocity vector is v2 bar, and when the particle is here, the velocity vector is v2. But the magnitude of v1 bar is equal to magnitude of v2 bar, okay, is equal to so on, is equal to v. I hope you understood now.
Yes,
The
sir.
velocity vectors are bending, their magnitude remains same. Now, any velocity vector in a system, if it has to change, what do you mean by change of velocity? It means either the magnitude has changed or the direction has changed or both has changed. In this case, only the direction is changing, the magnitude is not changing. Correct? That is why it performs uniform circular motion. Now, there must be some force to change the direction of the velocity vector. Right? And that force is what is acting on the particle. That is the centripetal force. Got it? Okay? So there has to be some centripetal force. And for this particle, some external agency should provide the centripetal force. Okay? Now, for example, here supposing you have tied a stone to a string. You have tied a stone to a string, and then you are revolving it, rotating it. Then the tension in the string becomes the agency for providing the centripetal force. Hello, are you with me?
Yes, sir.
Yes, sir.
Yes. Now, in the case of supposing this is moon, okay, and this is earth, okay, then the gravitational force here becomes the agency for the centripetal force. Got it?
Yes, sir.
Now, in the case of atom, this becomes protons, and there is electron. Now, the agency that is supplying the necessary centripetal force will be Coulombic forces. Is it clear?
Yes, sir.
You still have any questions? You ask, because now you see you have to start preparing for those examinations which are there 2 years from now. And what I am teaching now is a part of that syllabus. Don't think that PUC 1 and 2. PUC 1 and 2 is higher level than what you have learned in 8, 9, 10. It's a vertical progression. So you are supposed to enter the PU 1 and 2, 11th and 12th standard with clear, complete knowledge of 8, 9, 10. Alright? So if you have any questions, you please ask. Louder.
Because that electron.
Louder.
Because that electron do not have the considerable mass, so they cannot be like gravitational force cannot be.
There is gravitational force, but it is very, very negligible.
So Coulombic forces are.
Yes, so the scientist said, well, it is not sufficient, so there has to be Coulombic forces.
Means both gravitation and Coulombic forces
Are there, but it is the gravitational force in this case is very insignificant, so we will not take it into consideration.
So means Coulombic force, will it be also acting on the nucleus?
Yes, it is active. See, always see the gravitational force. Okay, the gravitational force between the two masses. They will be acting like this. So this force vector is because of this force vector is because of this. So there is Coulombic force acting on this and on this also. But since this is heavier, it does not move significantly. See, right now if I drop a ball, okay, the ball is falling towards earth. The force on the ball and the earth is same. But the mass of the earth is huge. So its acceleration is very, very less. And therefore, for all practical purpose, the ball is falling to earth, earth is not moving to moon. But theoretically, yes, it is there. Okay, see, these are fundamental doubts. You must get these doubts and you must clarify these doubts in the world. 0.001% also, if you have doubt, you must ask. You must not hesitate. Okay, there is nothing like understanding 99%, 1% I didn't understand. That means it's as good as not understanding. Alright, shall I proceed?
So, what
Huh.
is the Coulombic force?
Coulombic force is the force between any two charged particles. Okay, I'll explain that to you. Okay, now you see there is a charged particle. Now I'll explain what is meant by a charged particle, then you will understand that. Okay? Okay, see, for example, right now you have got, say, protons. Okay, so there are protons here. This is a charged particle, positively charged particle, and there is electron. Okay, electron is negatively charged particle. Now this will get between these two, because of between these two there is force, so the proton will get attracted towards electron, electron will get attracted towards proton. Just like how if you have two masses, M1 and M2, they get attracted to each other, same way these two will get attracted to each other. Okay, this is one. Now there can be a positively charged particle and Q1, and there can be another positively charged particle Q2. Then again there will be repulsive force on both sides. Okay, oppositely charged, they will attract, same charge they will repel. But in the case of mass, there is always attractive forces. That's the basic difference between the two. Okay, well, I will see this whole theory that I am writing here is with the understanding that you have studied gravitation in your last year. You are thorough with it, and if I ask you what is universal law of gravitation, you will be able to tell, right? With that understanding, I am teaching. Okay, but if you want me to tell you what is gravitation force, I will tell you. Right? See, when you have studied gravitation, can anybody repeat what is universal law of gravitation? Fast. Anybody, fast. You cannot repeat, I know. See, this is the problem. So you see, now this chapter I will be able to aram se teach, provided your 8, 9, 10, 8, 9 studied properly. But now if I ask you gravitation, universal law of gravitation, then you are looking at my face. So same thing is going to happen every year, so better be careful. Anyways, I will teach you now. See, what is gravitational force? Any two bodies, by the virtue of their mass, will attract each other. Say there is one body, there is another body. Both of them have got mass. They will start attracting each other. That force of attraction is called gravitational force. Now you have to be careful. So when you say body means it should have mass, correct. But there are entities in this universe which do not have mass. Alright, you will study, you will understand that as you learn more and more physics. Alright, now, so any two bodies, by the virtue of their mass, see, please appreciate and understand it. Now, when you look at something, it has got many properties. See, in physics, we call a cat because it has the properties of cat. That's all. So we look at the properties, and that two measurable properties, and we deal with it. I suppose all of you are aware of it. So if you take some entity, it has got so many properties. It has got many properties. Now one of those properties, see, for example, if you take electron, one of the properties of electron is it has got charge, and another property of electron is it has got mass. Maybe it has got other properties. Right now it is not significant for us. Correct? So therefore now, if you take, so therefore I say by the virtue of mass. So therefore I can have two bodies with so many other properties. A body can have charge and mass, like proton and electron. But gravitational force is only because of the mass. There can be other forces because of other properties. But we are not considering. At a time we are considering only the gravitation. Universal law of gravitation, what does it say? Consider 2 point masses. Consider 2 point masses. So when we tell what is gravitational force, we don't say point mass. Any two bodies will have force of attraction. But when you are defining universal law of gravitation, consider 2 point masses M1 and M2 separated by a finite distance r, not equal to 0. This is the condition. See, any law means relation. So here you see, you are telling a law, you are defining a law, and therefore conditions. What are the conditions? Consider 2 point masses separated by a finite distance r, not equal to 0. That means if the 2 point masses are touching, the universal law of gravitation is not defined. And if the 2 point masses are at infinite distance, then also it is not defined. So r should be finite. Okay? Consider 2 point masses separated by a finite distance r, not equal to 0. Then, if this is the condition, then there exists a force of attraction between the 2 point masses. So here I will call it as force on 1 due to 2, and this will be force on 2 due to 1. Force on this due to this, force on this due to this. There exists a force of attraction between the two, right? Now you see the magnitude of these two forces. I suppose you understand the symbol. Okay? Hello?
Yes.
Magnitude of these two forces are equal. Okay? In other words, F12 bar is equal to minus F21. They are equal and opposite. In accordance with Newton's third law. Okay, so consider 2 point masses separated by a finite distance r not equal to 0. Then there exists a force between the two masses, and this force is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. Inversely proportional to the square of the distance between them, and it is not affected by any other, it is not affected by the medium separating the two. Got it? Is that clear?
Last one, medium, what is
Medium. That means in between this, if you keep anything, if you keep water, wood, or if you stand in between also, this force will not get affected. Is that clear? Clear? Now, we are going to write this like this. So, finally, we write this force F. See, force F is only the magnitude. Okay? Force F is equal to G. Universal, because I said it is proportional. So, the proportional content is universal gravitational constant G M1 M2 by R. So, this is the force. Got it? Hello? Any question here?
Why they use that gravitational constant?
I want you to speak louder and clearer.
Why do they use that gravitational constant?
See, I told no, this is proportional, proportionality constant, no. You know proportionality constant, no? No, but this is the proportionality constant. G.
Well, anywhere it applies.
Everywhere means?
If you want to calculate the mass on the other planets, like specifically on Earth or like other planets?
Did I use the word Earth here anywhere? It is, I said mass. Any two bodies by the virtue of mass. It is not Earth. See, on Mars also if you go, this will be happening. Between Earth and Mars also there is gravitational force. Between Sun and Mars also there is gravitational force. Between you and me also there is gravitational force. But yes, we are attracted by gravitational force. But we are not coming closer because there are other forces which are more powerful than the gravitational force between us, because of which we are not coming closer. Understood? Because right now, what are the forces acting on you? One is, yes, you are attracted by all your friends, gravitational force, and you are attracted by Earth. But the Earth's gravitational attraction is huge compared to attraction by you. So therefore, that force vector is predominating. Other vectors become insignificant. Therefore, you are where you are. Got it? Any doubt you have? Alright. Okay. Now, as far as the Coulombic forces are concerned, right? Now try to understand this. So here for Coulombic forces, it is exactly similar to gravitational force. Here thing is, consider 2 point charges Q1 and Q2 separated by finite distance r not equal to 0. Same condition. Okay. Then there exists force between the two. See, in gravitation we said there exists attraction between the two. Now I am telling there is force between the two. Okay. So the force can be like this, or it can be like this. See, if Q1 and Q2 are of same type, then the forces will be repulsive. If they are of different types, then there will be attractive. And this force again, F12 bar, and here it is F21 bar, they are equal and opposite. Same. Okay. Now, but here the force is proportional to the product of the charges and inversely proportional to the square of the distance. Say like that. Only thing is point charges. Got it? Hello.
Yes, sir.
Now here F is equal to, now here the constant of proportionality is K, not G. Got it? G is only for mass.
Gravity.
This is Q1, Q2 by R.
R square.
This becomes the Coulombic force or electrostatic force. Got it?
Yes, sir.
Clear? Okay.
Yes, sir.
Done. Right.
K is just like constant, no sir, like.
Constant means, okay. Ask, I will explain. So, because I just told it's constant at this stage, but this constant will depend upon the medium.
This will depend on.
Depend upon the medium. See, if these 2 point charges are separated by water, then this force will be different. If there is wood in between, it will be different. If there is iron in between, it will be different. But gravitational force, it is independent of the medium. Got it?
Yes, sir. Yes, sir.
Sir, what is Q and Q?
Point charges. I'll tell you what is point. Hold on. I'll tell you. I have got one more slide where I will tell you what is point charge. I'll tell you. Hold on. Now, I think all of you know a lot of chemistry, right? You have studied periodic table and different atoms. I am taking copper here. So copper 29. So this is the electronic configuration of copper. Now why I am showing this is because from electrical point of view, of course, in chemistry, the electron in the outermost orbit becomes a valence electron, and that is important for chemical reactions. Now here for us in physics, this electron, which is the furthermost electron. Now please listen very carefully. Valence electron is valence electron, so it has its own definition. Okay. In physics, we have some electrons, of course, of the outermost shell, not all of them, which we call it as free electrons. Not all valence electrons are free electrons. So valence electrons and free electrons have no relation. So there are some electrons which we call it as free electrons, because you see the next slide here. See this free electron here, if you see here, supposing some other external this is a copper slab. I connect it to some potential difference. This is some battery I connect. Then some electron will enter this through the wire. Okay. So this electron which is entering through the wire, what it will do? It will come and occupy this place, and this electron will go and occupy this place. This electron will occupy this place, so on and so forth. In other words, that free electron can move through the material freely. Okay, it can freely move, but other electrons cannot freely move. Got it? Now here, this is very important for us in electricity, because this electron, because there are free electrons. Okay, so this metal becomes a conductor, and this plastic piece becomes an insulator. Why? Because there are no free electrons in this, so current cannot flow through this. But here the current can easily flow in this metal. You know, that's basically the difference. So there is concept of free electrons here. So that is important. Okay, because see, now you should not confuse. Valence electron is valence electron. Free electron is free electron. So copper has got some free electrons per unit volume. Iron has got different number of free electrons per unit volume, so on and so forth. It depends upon the material. It depends upon the material. Okay?
What is plastic? What is it?
It is an insulator. It does not have free electrons. That is why it is an insulator. Got it? See, this is how we have to understand the world. So if I say this is a conductor, current passes, why it's a conductor? If you say it's not a conductor, why? So physics explains that to you. Alright. So basically, this is how this is the atom from which I am using the concept of atom you have also used the concept of atom to study chemistry. Physics also is using the concept of atom to understand electricity. Right? Right. Now this is familiar to all of us. Okay, please read this. Alright, so this circuit is familiar to all of you, right? So you have got a battery, which all of you know, right? And then there's the switch, bulb, matter. And I am showing here a box and there is a matter in that. I don't know what is the matter. Hello? Yes. Now what I am explaining here is, well, see, now we have to use the right concept to understand the science. So here you see, as far as this matter is concerned, it consists of so many, matter, it consists of atoms and, molecules and all. But for us, from the point of view of electricity, it is a system of charges for us, right? It's a system of charges. So if a matter in the circuit that is here is some metal or metalloids. Metalloids means, in between metals and non-metals. Then bulb glows. They are called electrical conductors. They have plenty of free electrons. Got it? Now, if the matter is even aqueous solution of some sorts, that is, supposing you take distilled water, right? It is a bad conductor of electricity. You put 1 spoon of salt in that, then it becomes a good conductor of electricity. So that's what I said. If the matter is even aqueous solution of some salts, then also bulb will glow. But in the salt solution, there are no free electrons. Hello? There are ions of sodium and chlorine, Na plus Cl minus. So ions also aid conduction. So for current to flow in a matter, it should have charge carriers. In metals, the charge carriers are what? Free electron. ನೀವು ಬರೇ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂದ್ರೆ ನೀವು ಮೊನ್ನೆ ಟೆಸ್ಟ್ ಹಂಗ ಬರ್ತೀರಿ. ಇಷ್ಟು ಸಾಕು. ನೀವು ಬರೇ ಎಲೆಕ್ಟ್ರಾನ್ ಬರೋದು ನಾ ಕಾಟ್ ಹೊಡೆದು ಜೀರೋ ಕೊಟ್ಟಿರಿ. ನೀವು ಕೇರ್ಫುಲ್ ಇರಬೇಕು. All electrons are not free electrons. See, it's a very, very powerful concept. You cannot just take it for granted. Got it? So in metals, it is a good conductor. Why? It has free electrons. Now salt solution is a good conductor. Why?
Because it has ions.
It has ions. So ions and electrons are called charge carriers. They carry charges. There are many other charge carriers because they carry charge, Na plus, right? Then if the matter is glass, rubber, etc., then bulb does not glow. They are called insulators because they do not have ions also, they do not have free electrons. See, this concept of free electrons is extremely important for us. Then only you will study, because you have got in your chapter resistance. So series parallel combination of resistance. Then if you ask me what is resistance, how resistance happens, how does this material resist, then if you don't know concept of free electron, then I cannot teach you I cannot answer that question for you. So I am developing the theory for you to understand this electricity properly.
So,
Yes, please.
sir, how are metalloids conductors? Because they have non-metal cells which are insulators.
No. All, see, that's what I said. Not all metalloids. Some metalloids, okay? Some metalloids are conductors. Not all metalloids. Some metalloids are conductors.
So the metalloids which have more amount of metals, are they good conductors?
No, what do you mean they have more amount of metals means what? See, in the periodic table, you have metals on the left side and you have non-metals on the right side. So in between these two, one set of, if you see the periodic table from top to bottom, you will have certain elements which are in between metals and non-metals. So these materials are called metalloids. Correct?
Yes, sir.
Yeah. Right. See for example, silicon. Hello.
Yes,
Yes.
Silicon is a metal. Right? Things like that. So you see, this is why, periodic table is extremely important. You should be able to write the periodic table at least up to some 30-40 elements. Right now, if I ask you to write, you should be able to write. That's what should be the preparation here for 10th standard. Okay, then only you will understand physics and chemistry. Anyways, I am telling you, you try to do that. Okay, right. Okay, shall I proceed? Now, let's understand this charge better. Let's understand this charge. I have defined what is a charge. Okay, and that's the concept. That's basically a concept, right? But you see, if you tell me, sir, give me one proton, give me one electron, I cannot give you. All that you get is bulk. If you ask me at a time, give me 1 million protons, I can give you. Okay, I can give you this, right? But I can't give you one atom, right? However, you see, there is another concept called charged body. See, right now, this body contains equal number of protons and equal number of electrons. So, algebraically, if you add the protons and electrons, or algebraically, if you add the charge on the proton and electron, the charge on the proton and the charge on the electron is 1.6 into 10 to the power of minus 19 coulombs. The charge is same. So if you see now, use the word, how did I say you should add? Algebraically add the charges of protons and electrons in this. Then it will yield a sum 0. If you simply say add, then it can also be arithmetic addition. Arithmetic addition is addition of two things without any sign. Algebraic addition is addition with sign. Correct?
Yes.
Hello?
Yes, sir.
So when you algebraically add the charge of the protons and electrons, it will give you 0. Therefore, this is neutral. Therefore, this is neutral. But the nature is wonderful. For example, the other day I showed you something. You comb your hair, dry hair, and there are bits of paper. You bring it near that, then the paper is attracted. Right? And sometimes you see you walk on a carpet and then you try to open the door. At the knob of the door, you will get a shock. And sometimes you walk on the cement road with some nylon slippers or something like that. Then suddenly you try to hold the car handle, you will get a shock. Okay, so there are some experiences, or sometimes you sit on the plastic chair for a long time and then you try to get up and sit, then also you get a shock, right, etc. You have noticed this. Now here you see, this is the wonderful phenomenon. Now what I can do is I can take a glass rod, I can take silk cloth and I can rub it like this, right? I'll take one glass rod and one silk, I'll rub it, and then I'll take another glass rod and another silk and rub it. So I got 2 silk cloth rubbed and 2 glass rod rubbed. Now if I suspend the 2 glass rods like this, then they will repel. If I suspend 2 silk, they will repel. But if I suspend a silk and a glass, they will attract. Now observe very carefully. What happened here? Okay, what happened here? What is the physics behind this? Okay, that is precisely what I have written here. A glass rod becomes positively charged when rubbed with silk, right? And silk becomes negatively charged. Okay, this is what I have explained. Now what happens here is like this. You please read this. Due to rubbing, heat is generated which supplies energy for removal of electrons. Not all electrons. Some electrons, there are millions of electrons. Some electrons are removed. Removed means from glass the electrons get transferred to silk. So after rubbing, if you algebraically add the number of electrons and protons in glass, it will be more protons and less electrons. So deficiency of electrons means that body is positively charged. That body is positively charged. Now silk gains those electrons. So excess number of electrons, it becomes negatively charged. So somebody asks you, what is a charged body? Then you will say, if a body contains excess electrons, then it is negatively charged. If it has got deficient electrons, it is positively charged. So your positively charged body, negatively charged body. This is how we will explain what is charged body. If they ask you what is charge, then it is the intrinsic property of matter or whatever. Is it clear? Huh? So this is how you have to understand these two things. But this definition is not sufficient. You will understand this. Okay? Because if you want to understand what is electric current, because in the chapter they have said magnetic effects of current, chemical effects of current, so many effects are there. Then you have to have deeper understanding of this charge. Alright. Now here you see. You ask me what is a charge? Point charge. Due to rubbing, heat is generated which supplies energy for removal of electrons. As the work function of the glass rod is smaller than that of silk. So there is just like how in the chemistry you have got a charge by in the double displacement or a single displacement. You see, if you put copper in ferrous sulfate solution, correct? So what happened there? Iron in copper sulfate solution. So iron got displaced with copper, and in the electrochemical series, you know, this comes on top, this comes on later. Same way you have got the this series here. So if you rub glass with silk, glass will become positively charged, silk will become negatively charged. Like that, there is a series. Okay. So therefore, according to the series, you will have this happen. So the work function means that it's a concept. Again, now let me not get into that. So just like how you got electrochemical series, you have got the work function series. So it will tell you if you rub this with this, what happens. If you rub that with that, what happens. Right?
In that list, silk comes first and glass
Yes,
comes
glass comes next. Okay? And therefore, as the work function of glass rod is smaller than silk, it is in reverse order. Then it loses electrons to silk rod. Now the glass rod is positively charged and the silk rod becomes negatively charged. Clear? Hello?
Yes, sir.
Now, you see what I have done. Your question I am answering. If we take a very small particle out of each of the above charged bodies, that is, you have got a big rod, other one sand tukudi. You have got a silk rod, other one sand tukudi. Then you can treat them as charged particles. Got it?
Yes, sir.
Hello? I could have told you take proton and electron, but you cannot take proton and electron. So what we do, what the concept is that just we have got two tiny particles from this. So we can call them as charged particles. Got it? So I represent. If you take very small particle out of each of the above charged bodies, then they possess two significant properties, mass and charge. So I am representing the two charges. You can see here, the blue one is plus Q, M plus. M plus means mass of the positive charge. Minus Q, M minus means charge is minus Q, okay, and the mass is M minus. So charge is plus charged particle. You got it now? So I got two charged particles. Got it? Clear? So when I told you Coulomb's law, I told take 2 point masses. Sorry, for gravitational. For Coulomb's law, I said consider 2 point masses. Point charges. Sorry. So these are the 2 point charges that we take into consideration. Clear?
Yes.
Now, between the two charged particles, there exists force due to charges called electrostatic force or Coulombic force. The gravitational force of attraction due to mass is negligible compared to electric force in diagram, and so the electrostatic force vectors are shown in this. So I hope you understood that. So here I am showing you only two force vectors. They correspond to what? The Coulombic forces. Of course, I should show two more vectors here. Here, that is gravitational force, but that is insignificant. Okay, and here also I should show the two gravitational force vectors, but that is insignificant. Got it? So I am not showing you. That's what I want to tell you. Now, why I am telling this is because now you should be aware that this is possible. So they can give you two bodies which is point masses, point bodies, and it can have enormous mass and negligible charge. I can give you 2 point entities, particles, which has got enormous mass but negligible charge. Okay? Then the gravitational force can become significant. Or in the MCQ type of questions, they can ask you, given a proton and a proton, the force between them, A, Coulombic forces, B, gravitational force, C, both. Something like that. So now if you have understood what I told today, you will mark both. Understood? For practical purpose, when we are solving problems or things like that, well, the gravitational force becomes insignificant when you are considering what? Protons and electrons and things like that. But in the real world, you can have bodies which have got enormous mass and negligible charge. Then the gravitational force only predominates. And this is how things are tested for you in the competitive examinations. Please.
Like it will do protons also in that if you take two neutrons, they have negligible charge but they have mass. So
No, who told you neutrons has got negligible charge? I said neutron has no charge.
No charge.
No charge.
No charge means that time gravitational force only is there.
Yes, only gravitational force. Correct. That only is significant.
Electrons have the negligible charge.
Electrons have got
Negligible charges.
electrons have the charge on negligible mass. See, this attitude you should leave, man. You have to learn. See, you are trying to by heart. I showed you the chart, I showed you this one. See, you have got to be extremely attentive. See, electrons are very tiny things. So that's what protons are 10,000 times more massy than electrons. But the charge on both is same. That's what I showed you.
Yes, sir.
The mass of neutron is as much as the mass of proton. But it has no charge. Got it? Now, see, I am telling you, now recently the NEET examination results are out. So I told you, one of my students has scored 710 out of 720. His all India ranking is 60. You imagine, 25 lakh students, he is the 60th rank at the all India level. And there are two more friends, one of your seniors, Om Kawadi, right? And another Ijaz. All three of them have scored 695, 705, 710 marks, and all of them are eligible for AIIMS, All India Institute of Medical Sciences, prestigious institute, medical science institute, from Hubli, and they were all students here seated in front of me in the same chairs. They learned here from 8th standard. I have trained them from 8th standard. Okay, and they also cracked IIT Advanced.
JEE.
Yes, advanced. All three. So they can go to IIT also, they can go to AIIMS also. And they were all students from here. One from Rotary School, one from NK one from another Rotary, SR Babai Rotary. They are all students of this region only, sitting here and they did not go to any hi-fi coaching class or anything. Okay. The important thing is, if you see, I'll show you the testimonials. They said NCERT book pakka perfect. And if you take testimony of any student, see 720 out of 720, the student who scored the topper in NEET from Tamil Nadu, he says NCERT is the Bible, is the Gita, is the Quran. Okay, perfect it, that's it. Then today you must perfect this. And then you can take coaching and training. That is secondary. But if you simply go to coaching institute, they will coach you. They will provided, see, that coaching class will be helpful, provided you have the knowledge. Deep knowledge like this. Not superficial knowledge. Very deep knowledge. Because at every point you should question why. Then only you will get the proper answers. And why I am taking pains to explain all this is because what I found is, if you learn something wrongly and come to PUC, I repeat, if you learn something wrongly and come to PUC, or if you don't learn and come to PUC, there is no time for the teachers to go back to their 8th standard and teach you some fundamentals. They presume that you know the fundamentals, they will proceed. And what you will do is, with whatever wrong notion you had, you will continue with that, or whatever you have not learned, you will start assuming things. And okay, I think it is like that. Okay, sir, I have understood. You continue. Then you will have the debate. Okay, and you have got first year and second year portions together for the CET, NEET, and mains and all the examinations. first year, second year portion. Now you are having only chapter wise test, only this much portion. But there it will be tremendous portion. And that too deep. Okay, so therefore I am making sure that all of you get the requisites and proceed to the next unit. So whatever I am training you, it is indeed part of your syllabus, 10th standard, but more so ever, it is the preparation for your future examinations. Okay, so take a lot of interest and learn. Alright, so I have shown you this, that like charges repel and unlike charges, etc. etc. I have explained this. Clear? Now you see. Please read this. The moon and other satellites are bound to Earth because of gravitational force to Earth. The necessary centripetal force for all of them to keep revolving is provided by Earth's gravity. If they stop revolving, hypothetical, then they will accelerate towards Earth. Apple will fall to Earth. Why? It is not revolving around Earth. Okay. This, so here action, so accelerate. Action takes place at a distance away from Earth. See, moon is far away from Earth, but still moon is able to control. See, please appreciate. Now, if I want to push you, I have to come. My hand should touch you, and then I should push. It is contact force. So now, gravitational force, Coulombic forces are non-contact forces. They are not in contact with the body, but still they are exerting force on one another. Got it? It is 7:30. Okay. So action takes place at a distance away from Earth. This is called action at a distance. This is called action at a distance. Is it clear? Contact force, and these are non-contact forces. Okay. Pardon?
Once can you repeat that, action force?
Action at a distance. So gravitational force, Coulombic forces are all non-contact forces. See, now if I want to push you, I have to come in contact with you and then only I can push you. It's not that, boof, if I do and you will fly away. It's not possible. Got it? Now supposing you are a charged body, and supposing I bring another charged body here, then I can influence you. Got it? Otherwise, no. Now, this is important here for the next sentence. The region around the gravitational mass mg. So you have got Earth. Hello? Yes. Yes.
Action distance means like without any contact, the action is taking place. So like that.
Without any contact. See, now moon is controlled by Earth. Where is Earth touching moon? It is non-contact. Is it clear? If you have doubt, you ask. Only that boy is asking. I don't know. Sometimes she asks, sometimes she asks. He asks. Others also ask. Now listen very carefully. The region around the gravitational mass mg, wherein any other body with gravitational mass small mg experiences gravitational force due to mg, is called gravitational field of mg. Now what I will tell you. See, now here. This is Earth. So you have Earth. Okay. So you have Earth. Now anywhere you go, anywhere on Earth, if you drop a body, what will happen? Whether you drop it in America or India or anywhere, it will fall. Right? So now that means now around Earth there is a region, this region. In 3D you can imagine. Around Earth there is a region where in that region, if you keep another body which has got some mass m, see this mass is mg, big mass. If you keep another body with some mass m, that body will experience gravitational force. Correct now? Hello?
Yes, sir.
So the region where a body has some mass, by virtue of mass, gets attracted by another body, and that region is called gravitational field. Gravitational field due to this body. Understand? Gravitational field due to this body. Right now all of us are in the gravitational field of Earth. right? So therefore any body or any other body with mass, if you leave, it will accelerate towards it, because this region is called gravitational field. Is it clear?
Yes, sir. Yes, sir.
Okay. Now I'll show you why I am teaching all this. Extremely important. Okay. So you have got gravitational. So there is, the region is called, there is gravitational field, right? Now look at this diagram. In physics, a gravitational field is a model used to explain the influences that a massive body extends into space around itself, producing a force on another massive body. That means it has got mass. So you can see what it means is, so now this is, so where is gravity? Because see why this sentence is important. See, now you believe in what you see. Now if I tell you there is gravitational field here, so you got to, see, I told you I'll drop it, it is dropping. I did some things like this and convinced you that there is gravitational field. That is true. So therefore, you see, in physics, gravitational field is a model. See, they have created a model of it to explain the influences that other massive body extends into space, around it, producing force on another massive body. That means Earth is producing force on Moon or any body near it. So this is the model created around the Earth. Thus, the gravitational field is used to explain gravitational phenomena and is measured in newtons per kilogram. Now you can see this diagram, all of you. So there is one tiny spot in the center. What is the tiny spot? Point. Excellent. And then what do you see around it? No. What do you see around it? What do those arrows represent? It is representing vectors. They are vectors. Okay. Now carefully see those vectors. Okay. So if you see these vectors here at the center, okay, you see these vectors here. Okay. See here the vectors which are very close. Can you see those vectors?
Yes, sir.
You see their length. So the length of the vectors which are in the inner vectors, they are longer, and the next peripheral vectors are smaller, and the next peripheral vectors are still smaller. So what does that mean? So the intensity, the gravitational field intensity is more near the mass and it decreases as you go away from the mass. Got it?
Yes, sir.
Hello?
Yes, sir.
What else you got information from this? Look at this diagram.
Distance reduces, then the force.
Distance reduces, force increases. Okay, what else?
So the force is inverse.
Inverse. Okay, good. What else? It is attractive. Right. What else? It is symmetric. It is symmetric in 3D. Everywhere it is seen. Got it?
Yes.
See, my face is symmetric from left and right. From back and front, it is not symmetric. Got it? So it is symmetric. I hope you understood, all of you.
Yes.
See, this is how you see. You can now understand. Like But what are these vectors? These are gravitational field vectors or gravitational field. This is representing gravitational field. Okay. It by itself are not force vectors. Now please appreciate this. Now here is there any force acting at this point?
Yes, sir. Yes. It is.
No. There is no force. Listen here. There is no force. There is only field. Now if I keep this body here, this will experience force. Arthadala. Field and Arthadala. Now at this point there is no force. But at this point if I keep this body, this will experience force. So there is a difference between field and force. So there is gravitational field around. That means in that field, if you keep some body, it will experience force. That's the meaning of it. And the force experienced at this point will be lesser than the force experienced at this point, then lesser at this point. That is what is the meaning of this. The force experienced, see, if I throw the body from this height, it will experience some force at that height, but as it is falling down, its force goes, the force experienced by it goes on increasing. So the force is not constant. So the acceleration is not constant. That is why repeatedly when I tell you the acceleration on a body near the surface of Earth. So if you say acceleration is 9.8 meters per second square near the surface of Earth. But if you go very far away from Earth, hundreds of kilometers, then the acceleration due to gravity will not be 9.8. It will be 7, 6, so on.
It will be less now, sir.
Yes, it will be less. 7, 6. Okay, it will be less. Got it now? But as far as the 8th standard, 9th standard, 10th standard is concerned, as long as you are near the surface of Earth, you take it as 9.8 or 10 and calculate. Okay, so that is the idea. Now coming here. Similarly, instead of point mass, if you have point charge. See, I have put a positive charge here. Right? So if I keep a positive charge here and another charge, if I keep another positive charge here, what happens? It will repel. And if I keep a positive charge here and a negative charge here, it will repel. So around a charge also it has got electric field. Gravitational field, electric field. Now similar representation for this. Only thing is, if there is a positive charge, the electric field is diverging. If it is a negative charge, the electric field is converging. But if you see the nature of the vectors, they are similar. See, yes. In computer, I can generate this. But when you are going to answer in the answer sheet, okay, this will be difficult, so you can do this. That's the whole idea. Got it? Is it clear? Any questions? Hello?
Sir, magnetic field and electric
We'll come to it. We'll come to it. This you understood? I'll show you magnetic field. I'll show you. I'll show you.
Like 2 protons, if you kept, they will repel.
Wait. Now don't go beyond.
No, sir.
This is field. Now I have kept a positive charge here. If I keep another positive charge here, they will repel. Okay.
Both
Now
electrons are there.
both electrons are there also, they will repel.
So, means a proton is here, its electrical field is here, means if it has to repel, means the other proton must be inside.
Listen. Now don't use the word proton. Why you want to use the word proton here?
Positive
Oh,
charge.
proton is over now. See, that's why I took you from atom to a charged particle. I have taken you from atom to charged particle. Now don't use protons and electrons unless it is necessary. Use the word charged particle.
Means a
Positively charged particle, negatively charged particle. Start using those terms.
a positively charged particle is there, sir. Means its electrical field is here. Means it must repel with the other positive particle. Means it must be inside the field, sir.
It should be inside.
Means the other positively charged must be inside.
Must be inside the field. See, now I am standing here. So this is the field. So if another point is here, it is inside the field. Now, frankly speaking, if the gravitational field of Earth is extending up to infinity. Only thing is the intensity keeps on becoming lesser and lesser. So if you go beyond a particular point, the gravitational field of Earth is negligible. So for all practical purpose, the gravitational field is 0. See, you please understand all these things very carefully. Okay. Now if you hit a bell, church bell, dun, the sound starts decaying. Theoretically speaking, it will decay after infinite time. But for all practical purpose, once you cannot hear it, it is as good as it is not vibrating. So Earth's gravitational field or electrostatic field, electric field, they extend up to some region significantly. After that, it becomes insignificant. So for all practical purpose, it is not. Got it?
Yes, sir.
Any other question? No question. So I suppose you understood this, because we are going to use all these concepts. Then only you will understand electric current. Otherwise, you will not understand electric current. All these circuits I am doing because for electric current. This is magnetic. magnetic field due to earth. If you keep a bar magnet also, you will get the same. Got it? There is the part. Now, see, important thing about gravitation. Similarly, a magnetic field can be defined. So, you have a chapter on magnetism and magnetic materials in second year PUC. So, you are going to study this in detail. Electric charge in motion. See here, electric charge in motion creates both electric and magnetic fields. So, if an electric charge is at rest, it creates only magnetic field. If an electric charge is in motion, you get around it both electric field and magnetic field. And you have that in your 10th standard. Moving charges and magnetism. The chapter is there. Next chapter. So, electric charge in motion creates both electric and magnetic field.
It is rest the only electric.
Yes. So, it is in motion, it creates both. What happens if a charge is moving in magnetic field? What happens if a charge is moving in a magnetic field? Now, if a charge is moving, it will create, it has around it, it has got both electric field and magnetic field. Okay, how it will be seen. Now, this will be like this. Okay. Okay. Now, if a charge is moving like this, okay, so this is plus Q charge. So, everywhere there will be electric. At a given instant of time, I am telling you. At a given instant of time. Okay, and if it is moving like this, here there will be surface. That is, the charge is moving, there will be concentric magnetic fields. Yes, see now in this plane there will be magnetic field, but in this region there will be electric. I will explain this tomorrow. Okay, I will explain this tomorrow's class, but right now it is like this. So you understand this. So these are all the fundas. More fundas are there. Tomorrow I will cover it for all of you. You have any question, you ask. All these topics what I am doing is with regard to your second year PUC. You must understand like this and go to your PUC first in detail. Then only you can do something. Otherwise, any amount of coaching, any amount of money that you spend will be futile. Knowledge ittu coaching ka training ka help ಆಗ್ತದೆ. You may be intelligent, but if you don't have sufficient and proper knowledge, then no use. Because intelligence is all about applying the right knowledge at the right time. You might have got some knowledge, but not all knowledge. But for those examinations, you must have all knowledge. Then only you can crack. That is the secret of all those examinations. Okay? Anyways, all the best. See you tomorrow. Bye.